Hi, I'm Nicole Hutchison. I'm the principal investigator for the Helix project, which is a 8-year study that we just wrapped up this year. And also on the line with me is Dr. Yancy Tao, who is another researcher on our project, and she'll share with you some of the specific results from this year as well. So I think, we've been around for a bit, the Helix program, and many of you might have heard of us, but just a little bit of background. We initially launched in 2012. We started out focused on what made individual systems engineers effective, so at the individual level, and over time evolved to what it means for an organization to be effective at systems engineering as a capability. We've done a lot of data collection over the last 8 years, including in-depth semi-structured interviews, surveys, and also pilot work with organizations. We've briefed a lot of this here at the SSRR. We've briefed at the INCOSE conference, IEEE SysCon, NDIA Systems conference. So we have a large library, and I'll share with you all at the end a link to our website where you can look at any of our resources. But I just wanted to be clear that I'm sort of giving an overview instead of specific research findings, more how we're transitioning this research that is completed into practice. So just wanted to set expectations there. And just a quick reminder, our IRB protocols stated that individuals and organizations that participated in Helix were protected via anonymity. So there are a few organizations that have stood up in public and said, yes, we participated in the Helix study. So I might mention one or two of those because we're allowed to once they say it publicly. But, I just can't answer specific questions about who participated. So please don't ask me. So the research questions, as I mentioned, have evolved over the last 8 years. And the first question started about individuals. So what are the characteristics of systems engineers? And interestingly, this one more started out as sort of who are the systems engineers in the Department of Defense and how many are there? Because there wasn't, at least at the time, a specific job code for systems engineer. And so it wasn't easy to identify who those people were. What we found is we had to actually start by classifying and categorizing what a systems engineer was in order to even start those conversations. So characteristics of systems engineers, and then what makes them effective and why those things make them effective. We were also at that time looking at what organizations could do to improve the effectiveness of their workforce. And you'll see that under organizations as we transition from focus on individuals to organizations. That's kind of where we started. So at the organizational level, we want to understand not only the effectiveness of individuals, but how do those individuals come together collectively to create a systems engineering workforce? And how does that workforce impact systems engineering? And then what are the other factors that influence effectiveness? And basically, what do organizations need to do to change what they're doing in order to be more effective at systems engineering? One of the questions, this last one that we did ask ourselves was, does this differ if you're doing different systems engineering approaches? But most of the organizations we talk to, they might do MBSE, they might do some other things, but for the most part, they followed kind of a traditional life cycle model, V model approach, or some version of that. So we didn't actually get quite enough different types of systems engineering or flavors to be able to really draw crisp conclusions about what's different depending on your approach. And so maybe that just means that what we found is more generalizable. That's not necessarily bad. So here's our data set. After 8 years, we have 31 organizations that we've worked with. We did in-depth interviews with 287 people, as well as over 200 survey responses. These survey responses were not, 2 questions and you're done. These were in-depth surveys. It took about 45 minutes or more to complete. So it's quite a lot of data in those survey responses. As well as you can see 6,000 pages, over 6,000 pages of transcripts. Our sample set is 3/4 systems engineers and 25% what we've put on the slide as peers. It's actually their colleagues, their managers, and their leadership. And just like any good study, good systems engineers, we don't want to just assume that we're right. We want to trust but verify. And so those 25% are our way of getting feedback on what we're hearing from the systems engineers. And when we talk at the organizational level, that's actually also where we get a lot of insights on what's going on and where the pain points are that are making systems engineering less effective, because the understanding and expectations are different for the different stakeholder groups. Just really quickly, a little bit of data information about our data. So I mentioned the transcripts. We did qualitative analysis for a lot of our interviews. That's where most of the findings came from. We started with grounded theory, which means that instead of going in with a framework and trying to verify it, we actually let the data speak and use that to generate our findings. We have the 6,000 plus pages of transcripts in Word and in the in vivo database. We also have transcripts that were cleaned via script. Those were specifically used for more data analytics approaches. We briefed on those primarily last year. But we also have the data in those tools. And then the survey responses we have in Excel because it's easy. And then we also use some data analytics tools specifically for mining the free text responses of the surveys to try and improve our sense making from that. So all the different data, that's kind of how it shakes out and what tools we've used over the last 8 years. So I mentioned that the task is completed. So we wrapped in July, and this research task is officially over. But what I want to talk for a little bit about is the transition from research to practice. And we have had a number of pilots with organizations. So there are organizations that have been using Helix, some for several years, to improve their workforce, to understand their workforce and understand themselves. And there's a lot of good work that's come from that. But specifically in terms of transition, we've developed web-based tools that will allow us to make it very easy for individuals and organizations. Okay, it sounds like someone's trying to call. I will ignore that and hopefully that will stop soon. The tools that you see here, we have two sets of tools. One is focused around individuals and the other around organizations. And they both use an SQL database to store the information. And what we're working on right now is actually getting those tools, which were developed independently, to talk to each other so that an organization can understand not only have self-awareness at the organization level, but then also have insight into the individuals who are in that organization. So we're working on those right now. And then you see these pieces here in the lower right. These are not things that we developed, but things that we used as part of the research successfully and that we're also using in the transition. So these are two different measures of culture in an organization. The Chi Index is all about culture that supports innovation in teams. And the competing values framework is really just an overall cultural assessment. It has 4 different attributes, and it sort of says how strong are those different attributes in your organization. Things like, do you act like a family? Are you innovation focused? Are you very rigid in your approach, etc. So that's kind of the overall flow of the tools that we currently have. And then what you see here is this organizational report. We have created individualized reports for some of the organizations that we've worked with over the years. And one thing that we'd like to do is actually start offering that as a service. So the tools will get organizations so far, but the researchers with all the data and experience behind us can then create individualized organization reports. Research findings, again, I'm not going to go into this in a huge level of detail, but basically we have one, and of course my dogs are barking, sorry about that. We have one major document that has all of our findings in it, and that's what we call Atlas. It's our theory of systems engineering effectiveness at the individual and organizational levels. We've created an implementation guide, so you as an individual can use this to map your own career, understand your skill set, etc., as well as guidance on organizations, some of that coming from the organizations that we've worked with. As part of the research, we also created something called the Career Path Guidebook. We mapped the careers of 157 of the people in our sample and basically did analysis and looked for patterns, and specifically patterns that related to certain skill sets. So what kinds of experiences, for example, lead to what kinds of skill growth? How far does undergraduate or graduate education get you along the growth in your skill set versus, what things are better provided in training or mentoring relationships. We have lots of technical reports and findings, of course, and I mentioned the library of all the articles that we've written over the years. That's on our website. And then finally, the two tools that I mentioned a minute ago, the tool set for individuals and the tool set for organizations. And so as we move forward with Helix and trying to get the community to embrace and adopt it, these are all of the materials that we have, and I hope that you'll agree that this is a really rich set of content. And I just want to say that these are the sort of two frameworks for individuals and organizations. What you see on the left is our theory of systems engineers effectiveness. And it basically says an individual is effective when they consistently deliver value. They work in the context of an organization. That organization determines what the organization is looking for in terms of value. The organization also identifies what roles and positions people can play, and hopefully there's a mapping between that and the person's proficiency, their skill set. And then finally, there are characteristics of individuals and organizations that come together and they influence how a person can grow, which we call the forces. That's really your career path, your experiences, education and training, and mentoring and coaching that influence your growth over time and your ability to deliver value. We get a comment fairly frequently that that's pretty high level and generic, and yes, it is. That's actually intentional. We wanted this to be something that, even though our research is specific to systems engineering, that was more generalizable, and I think that we've been successful with that. At the next level down is where you get into the details of systems engineering. So what does value mean? For example, setting and maintaining the system's vision, getting a diverse team to embrace and move towards the system's vision, helping teams make decisions at the systems level rather than optimizing at subsystem level. For one other example that we talk about a lot is translation. So systems engineers tend to provide value by helping engineers understand business concerns, help business leaders understand engineering concerns, etc. So that's the individual side. And then on the organizational side, you see these boxes here, the workforce, which are comprised of individuals, and then the team. So it's not just the systems engineers, but all of the other people that they work with while they're working on development and other activities. That all happens in the context of the organizational culture, and you'll see that culture touches just about everything, and that's very true. I don't think that should be a surprise to anyone. It aligns with a lot of information on organizational leadership, and culture. But culture influences everything. Leadership and governance and structure do as well. And then here you see the organizational key values. And again, specifically for our research, we're talking about key values delivered for systems engineering, but identifying what those are and what it means to effectively deliver systems engineering capabilities. So what you're seeing here is kind of this piece, and then you have this picture for a lot of individuals. That's here. Then how does that scale up to the overall organization? And so those are kind of our two main frameworks. So I just wanted to give a quick overview of that. Again, happy to answer questions or share more detail on that. So that's the context on which we built the tools that I mentioned earlier. So for individuals, this is the tool that allows you to assess your skill set. And we basically go through the proficiency model that we've generated. It starts with your STEM foundations. So what math, what science are you using to build upon? What engineering principles do you understand? The domain context that you work in, the discipline of systems engineering itself. So what kinds of architecture do you understand? What are you able to do in terms of requirements? Do you understand configuration management, et cetera? Systems mindset, which is my personal favorite, what we call paradoxical mindset, which is not just big picture thinking, but also being able to focus on details, have the judgment to know when you need to do one or the other, abstraction, etc. And then the two quote unquote soft areas of interpersonal skills and technical leadership. So systems engineers ideally should be leaders. They should be able to bring together diverse teams. And that is certainly a difficult task, even if they are soft skills. So this tool basically gives people the information they need to self-assess where they fit on that spectrum. And then it'll give you graphics. And what you see is you can track your growth and progress over time, and you can set future targets. And using the career path guidebook, you can then say, okay, I really need to grow in terms of domain knowledge and operational context. And what you'll learn in the career path guidebook is that there's, training might help address this a little bit, getting basic terminology down, that sort of thing. But to really advance in this, you've just got to have experience. And so that might be a place where finding a mentor who's specifically going to help you focus on what's unique about that discipline might be a more helpful thing. So this allows you to track, again, your proficiencies over time, and then plan for how you'd like to grow. And then the other piece for individuals is mapping your career paths. So I've mentioned the career path guidebook a few times. What it basically does is give you a visualization for the different jobs you've been in. What aspects of systems engineering have you actually done? What roles have you played? I apologize, I accidentally scrolled, I didn't mean to. And it gives you a very quick snapshot to say, I've never really worked at the very front end of the life cycle, generating the high level concepts for what systems should be. I haven't really done a lot with requirements. Maybe I should do that. Maybe that's an area where if I can get some opportunities there, it'll help me grow because I'll be seeing more of the life cycle, etc. Sorry, one more time. And then what you see here is taking those two pieces and putting them together and helping you identify your own patterns. And again, we'd like to get to the point where we can actually provide this level of insight for individuals in the workforce across an organization. And then for the organization, we have a tool that is based on how we conducted our survey. We've edited it a bit. We've excluded things that we didn't think were actually very helpful or didn't yield useful survey results. And what this does is you can have a variety of individuals in your organization take this, and then it will actually give you a dashboard where it gives you basic analysis about these different factors. So the first are the competing values framework I mentioned. That's the cultural assessment. Then you have specific questions around culture where it says part 1 here. That's specifically culture about systems engineering. So what is it that goes on when systems engineering happens? What's the way you do business around here? What decisions do systems engineers help make? Where are they expected to provide guidance and leadership, etc.? Governance really talks about, what is sort of the plan. So culture in some ways is how things happen. Governance is how they're supposed to happen. And comparing data between the two sometimes also yields valuable insights. What methods and tools are being used. Some very targeted questions around effectiveness and value. And then the quality of interaction index I mentioned, which is about teaming and innovation. So again, organizations can then get a snapshot of what they're seeing. So for example, this might be systems engineers. This is their peers. And for the competing values framework, we actually ask current and future directions. So what you'll see is almost every time. No one thinks that exactly how things work right now is the best way. And so what we look for are the patterns in how people think the organization needs to evolve. What you're seeing here is that it tends to be pretty rigid and structured. And overall, both systems engineers and their peers agree that it needs to move to be a little bit less rigid and a little bit more innovative. The Chi Index, which was developed by an organization called Human Insight that we pair with to do additional analysis, basically says that the sweet spot is right here. A generative culture which is cognitively diverse. It means people think in different ways. It's common to have different viewpoints, and also psychologically safe. So not only do people have different viewpoints, but it's okay for them to express them. And that's not only okay, but encouraged in the organization. That's the sweet spot here where real innovation is generated. That's this generative quadrant. And what you'll see, this is one organization and then 6 different divisions within the organization. That's what you're seeing here. And you can see, even though the aggregate looks pretty good, when you actually look at the spread, you might be able to then say, you know, actually a lot of Division A is showing within this generative space. But wow, Division C has a lot more spread, a lot more focus on oppositional or uniform. So what's the difference? What's going on differently between those 2 parts of my organization? And that's the type of thing when we worked with companies as part of the research, we would sort of help them tease out what was going on there. And again, some of these results you just get as part of using the tool. You see all that analysis updated in real time. This particular one, we have to work with Human Insight to get this because this is their proprietary algorithm. Again, we ask questions like how effective is systems engineering, and that's related to how it's organized and a number of other things, but it gives you a sense of how things are going, how your employees are viewing things. And then another way we can do this, and I mentioned those organizational reports, we can do things like look at teams. So instead of this being past, present, and future, think of this as a team structure. Well, maybe technical leadership is an area where you need a lot of people really strong here, but right now you don't have people that are there. So from a workforce perspective, let's focus training and mentorship around that. You can also look and say, you know, what patterns are we seeing? So people generally agree in this organization that the way systems engineering is organized is effective, and that is a pretty good match between that and how effective people believe systems engineering is. It's great that no one thinks it's very ineffective, but no one thinks it's highly effective either. So what's going on there that no one thinks that it's very effective? And then we can look to other things like how clear are the roles of systems engineers, and maybe part of the lack of effectiveness is that people aren't always exactly sure, and peers think they know what systems engineers should provide, but they're actually more certain than the systems engineers themselves are. So there's a disconnect there, and that's an area where you can pinpoint some tension and apply a little bit of targeted communication and work to really make a big impact in your overall effectiveness. So those are the types of things that we can do with the tools that we've generated. So that was a very quick overview of everything that we've kind of done in the last 8 years and where we're trying to transition. We did try one thing different this year as part of the research itself as we were wrapping up, and that was to use automation a bit more. So I'm going to turn things over to Dr. Yancy Tao and let her tell you a little bit about the automation work over the last year. Yeah.
Nicole, so we have the automated analysis. Next slide, please. These are the questions that we explored as we're trying to understand the different aspects by analyzing the aggregated transcripts and visualizing them through the creation of our systems engineering analyzer dashboard. Next. This is the framework that we developed based on an adaptation of a multi-level architecture framework to better understand the roles and effectiveness of the workforce at these 4 different levels. As you can see, we have the community, industry, organization, and people levels. This has been developed using a computer-assisted content analysis, which is a text-driven approach for this web-based application. Next slide. The data input, as we mentioned earlier, were all completely raw textual information from all the interview transcripts, which has been cleaned through pre-processing using basic text mining approaches like tokenization, stop words, lemmatization, etc. Word2Vec was used when we developed the systems engineering knowledge repository so that we can train the word embeddings. So phrases that have similar concepts were grouped together so that we can actually use them and understand them together. Sentiment analysis is one of the most common techniques used. This will help us to automate the process whether any given text is positive, negative, or neutral. So we've used an iterative, semi-supervised sentiment analysis approach combined with human expertise so that we can create a high level of accuracy in coding interviews. Next slide, please. Let's take a look at the dashboard. In this first view, you can look at the different word clouds. So on the left, you will see the repository of the first three on the top, where you can actually look at the systems engineering knowledge repository, where we have gathered a lot of publications, open source literature, such as the INCOSE handbook, systems engineering handbook, as well as other publications, also focused on organizational culture, structure, strategies, governance, and processes. These have helped us to build our vocabulary as well as the taxonomy for the dashboard. Then you have on the bottom, you'll see a couple where we talked about the different intersections. So we looked into comparing systems engineering and culture. What are the specific word clouds and specific prominent phrases and topics that would pop up? Next slide, please. In this second tab, it compares all the different systems engineering topics in the interview transcripts across the 6 domains. Here you'll see commercial aerospace, defense, healthcare, high tech, IT, as well as transportation. So systems processes include the system implementation and development, and then you have systems engineering management and tools, people and team, organizational culture is the last. When you hover over each domain or topic combination, it shows an example of sentences that belong in each group. So for example, that we have a large chunk of interview data that's on the systems implementation and development. And in IT, you have more focus on people and team. Next slide. In this detailed view, you are able to look at the heat map, and the heat map shows the normalized phrase frequency for each phrase in the domain. For example, under the drop down, you can look at, we're looking into the risk analysis, which is one of the focus areas. The darker the color, the higher the normalized phrase frequency appeared, and vice versa. So in this case, you can see in defense, for example, program risk and risk management were identified more frequently. Next slide, please. In this analysis, we're looking into the culture. And so these are some of the questions and statements that we asked our interviewees. And in this one, we asked about if the status of systems engineers in their organization, what is the status? And as Nicole mentioned, we use Likert responses. So in this case, in level 5, which is strongly agree, we can see a lot of the organizations that have agreed that this is high, and this is a summary statement that is populated from the system, which lists and state that systems engineers are seen as technical specialists and as technical conscience of the product teams. As such, the value that systems engineers bring internally and externally is considered critical. Next slide, please. So here are a few of the major contributions from this dashboard. We found that we were able to develop a systems engineering knowledge repository. We were also able to find patterns based on the effectiveness of the workforce at industry and organizational levels. We were able to gather and aggregate a lot of the concerns and accomplishments of the people at the individual level as well. And finally, this is definitely an example and a good point of entry for text analytics and interactive dashboards for researchers using data from interviews for analysis. This dashboard definitely has potential to be further developed so that we can support more systems engineers and their organizations and as they explore the effectiveness of the workforce and enable the systems engineering capabilities. Back to you, Nicole.
Thanks so much, Yan. I really appreciate you reviewing that. And as Yan said, you know, this is research, so not everything pans out, or not everything, you know, goes as far as you would like. That's where we were by the end of this year. I think there's a lot of potential there. So it'd be great if there's another project that could use these types of things like the dashboard to be able to reuse some of that. Just want to wrap up our time here with a couple of thoughts. And I mentioned that we had this desire early on to keep Helix generic enough that the higher order principles kind of apply across the board. As we started working on transition, Tom McDermott, who many of you may know, has been helping us look at Helix and figure out where it should go. And as part of that, we've actually been looking at, you know, does Helix give you a framework not only for specific for systems engineering, but with a few edits, does it actually help you create a framework for developing complex problem solvers? And so I mentioned those 6 proficiency areas earlier when we were talking about the tools. And if you rephrase them just a little bit slightly, they actually align really nicely with the existing literature on complex problem solving. And as you can see from the World Economic Forum in 2015 and in 2020, complex problem solving is the most in-demand job skill. So if we have perhaps inadvertently stumbled across a way to really help build that skill set, that has great potential for impact, not just in systems engineering, but in the world. And so we've been looking at a platform called Journey. I don't know how many of you may know her, but Dr. Ruth Crick works in the UK. She has spent many years on research of learning journey and learning power. And she has created a platform called Journey to help people understand their learning power profiles. And so what we think is that combined with the organizational self-awareness I talked about in terms of the way that Helix can help organizations understand themselves, as well as the focus on complex problem solving combined with learning power, is really a strong potential platform for complex problem solving development. And so we are looking into options for that, and we're pretty excited about it. So again, we're working on sort of generalizing Helix for this broader skill set. It involves, again, complex problem solving and learning power, capacity for learning. We're looking at teaming up with Journey and what that would actually look like and entail. And again, the Helix tools as well as the Journey platform might be the way that we bring all of that together. So not done yet, but as part of the transition, I think this has great potential to show the power of this type of research in not only systems engineering, but overall in the kind of innovation and technology space. So very exciting, and we're definitely looking forward to that. So last but not least, what I would like to do is acknowledge the team. You can see not only myself and Yan, who are talking to you today, but 27 people are on this list. So we've had a lot of people working over the years. Really appreciate the entire team. I get to be the person metaphorically standing in front of you and briefing, but without all of these people, all of this great research never would have happened. So many thanks to the team. Thank you very much for your time and attention. This is our website. Again, feel free to visit, feel free to use the tools and download things from our library. And with that, we'll happily take questions. Thanks so much for your attention. Hope you have a good day.